Okay, let's look at this question. Okay, we have a force and a radius graph. So the force is in newtons, okay, and the radius is in meters. Okay. The area under the graph has a unit. So say the area under the graph, okay, it has a unit of Newton meters, okay, which is the unit of energy, joules. Okay, so the area will be the work done, okay, or energy. Okay. Now, so I need to find. Okay, the question asks me to find the work done, which is the area under the graph. You mentioned that you get 1 mark. Okay, from 8 to 10. From 8 to 10. Okay, remember is million meters. Okay, 10 power of 6. I'm sorry, times 10 power of 6 meters. Now, okay, then we need to find the area. Okay, however, let's just remember for math students, okay, I know you're good with math, okay, but in physics, in VCE, okay, the examiner is not going to test you how your math is. Okay, so you don't need to use calculus to find the area under the graph. Just draw a straight line, okay, and treat this shape as a trapezium. Okay. Now, you still get the right answer if you use calculus, but it takes too much time, especially say imagine during the end of year exam. Okay, just you need you need to save some time. Okay, just treat this shape as a trapezium. Okay, so the area of the trapezium will be half, okay, the base 300 plus the top 200 times the height, okay, which is 2, okay, times 10 power of 6 meters. Okay. Put it in your calculator, then you will have 5.3, okay, times 10 power of 8 joules of energy, okay, which is the work done. Okay. Also remember to um, to use two significant figures. Okay. Now, yep. Yep. Well, because it's mentioned here 2.4, so just use two significant figures. Okay. So, sorry, 6.4. So that's it has two significant figures, means the accuracy of the graph is in two significant figures. Okay. So, yep. Okay. You write down this, you get 1 mark. For final answer, you have another mark. Okay, now let's look at a more complicated question. Okay, so here we have again, okay, now in this case, the gravitational field, so the unit will be newtons per kilogram. Okay, now horizontally, I have a meters, the unit will be meters. Okay, so the area under the graph, okay, should have a unit Newton meters per kilogram. Okay, just times them together. Okay. Newton meter is joules, so the energy, so the unit will be joules per kilogram for the area under the graph. Okay, so it's basically your work done, the energy per kilogram. Okay, now now let's read the question. So I have a height. Remember, it's a height. It's not the radius. Okay. Now, okay, and I have a speed. Okay, velocity. I need to calculate the energy needed to take 400 kilogram space from rest. From rest means the height will be 0. Sorry, from rest at the surface of the Earth, height will be 0. In to this height. So basically, I need to find the area under the graph from 0 to 1.7. So that's 0, that's 1.246, 7 is in between. So I need to find, yep, that's 1.7. I need to find the area of this. First. So again, treat as a trapezium. Just treat it as a trapezium. Don't bother to use calculus. Now, it's a 5-mark question. Step 1, I mention the area under the graph will be the work done. The energy per kilogram. We did it here. So mention it, you get 1 mark. Then find the area. So half, if I read that, you only need to give a approximate number. So 1.7. So it's about 6.2. So half. 10 plus 6.2 times the height. So times 1.7 times 10 power of 6. Then if you put it in, it will be 1.7. Give me a second. You would have a number. So I don't have a calculator now. Just remember, put it in. Now the important thing will be the unit. The unit is not in joules, but in joules per kilogram. Write it down. Joules per kilogram. Now, after that, I need to find the energy needed for 400 kilogram. So the energy will be 400 times this number. Now, this number here. Times this number. Then you will find your answer. So when you do this question, just give me you got 1 mark for this. You get another mark. Also, after you do that, you get 1 mark. Also, you get 1 final answer. I think 2 final answer mark. In this case. Remember the unit. In joules. Finally. Now have a look at this question. So we have during the space shuttle launch. Now an astronaut experiencing apparent weight, so its normal force equals to 3 times her normal weight, so 3 mg. What is his acceleration? So just remember, apparent weight is your normal force. So let's draw a diagram. Now, a mass has a normal force equals to 3 mg. 3 times its normal weight. And downwards, it has a weight force of mg. Newton's second law, the net force, okay, will be the sum of all other forces. Okay, so normal force take away the weight force, which is acting downwards. Okay, so I have 3 mj take away mj. Okay, the net force will be 2 mj. Okay, so F equals to ma. 2 mj equals ma. Okay, my acceleration will be 2j, okay, which is 20 meters per second square up. Okay, now, okay, have a look at this question. Okay, now, which of the following statement describes a situation where a person in a lift, okay, near the sand surface of the Earth would experience apparent weightlessness? Okay, so, well, let's do this. Let's do a scenario. Okay, now, so I have a person. I just draw a block. Okay, here. Okay, I have a normal force acting upwards, and the weight force goes downwards. Okay, now I want apparent weightlessness, so normal force must equal to 0. Okay, so my normal force has to be 0. Okay, and I need to know whether it's moving up, moving down. Okay, so I need to find the acceleration. Okay, so say acceleration is unknown. Okay, acceleration is due to net force. Okay, net force is the sum of all forces, Newton's second law. Okay, so my net force will be my normal force take away the weight, the true weight force, mj. Okay, the net force is ma. Okay, normal force will be 0 equals to m minus mj. Okay, the mass cancels out. Okay, my acceleration has to be minus the gravity. Okay, so basically it means it has to accelerate down. It has to accelerate, okay, downwards. Okay, so downwards. This must be your answer. Say, okay, down.